In our previous video, which was an introduction to one-dimensional arrays, I showed you this program, and I want to use that very same program again here. So we had several arrays that we declared, as you recall, and within the program we did a few operations with them. We initialized them, we did print them out, and we did some addition, subtraction, and so on. In that program, we had a lot of things that we repeated. In particular, we were printing out array 1, array 2, so we had this for loop we used over and over again. Whenever you have a situation like that, you have a lot of repeated code, then that is just crying out to be made into a function. So we are going to now modify that program, and we're going to add in some functions and illustrate how to pass an array to a function by doing so. So starting with the with the program that we just did, let's go down to the first part where we are initializing the arrays. Now this wasn't very much code. We didn't repeat it, but I want to make this into a function as well. So whenever I want to initialize an array, I'll call the function, and the function will initialize the array. So let's look at the mechanics of how we go about doing that. So first we need to have the function, and let's just go down to the bottom of our program where functions live, and let's add in a function down here. So we're below the main program, and I'm going to add in a function to do initialization. So I'm just going to copy and paste the code here so you don't have to watch me type. So let's look at this initialize array function. I've added some comments below the main program to tell me, hey, the functions go down here. Then I need to write a function to do the initialization of an array. I'm going to make this a void function, and I'll explain why coming up. And I'm going to name the function init_array, and it has two formal parameters. So there's an integer, and it is an array. And when I declare something to be an array in a function, then I can just use the empty square brackets. I don't have to put a specific size here. In fact, it's an advantage to not put the size there. I'm going to pass in how large the array is in this formal argument called elements. So in the case of the arrays we're working with, that'll be 100. So it's a void array. We have the name, and we have the two parameters. And the important thing to remember is you can use the square brackets to indicate that this variable is a one-dimensional array. Now let's put some code in the middle to implement this function. So let's paste that in. So we need to have a loop control variable I. I've declared that I is an integer here, and you can also just put the declaration in there if you want to. You could do int and I equals 0 right there, and you wouldn't have to do it up here. Okay, so just whatever your preference is. So I'll take that back out. So now the for loop starts with 0, and it goes up to the number of elements for the array that we pass in. So that means I could send in an array with 10 elements, with 100 elements, with any number of elements that I want, and this function would work just fine. So then inside the loop, it's pretty easy. We just want to generate the random numbers, and we want to put them into the array. Now notice that the name of the formal argument is array n. And when I call the function, I'm going to call it with array 1 and array 2. So it doesn't matter what the name is in the function. It doesn't have to be the same as the main program or the calling program. So any array that I pass in, the formal argument array n will take on all those values. So in the function, I'm going to use the variable array n, and we just increment through the entire array, and we generate a random number, and we store it there. Moving along, we have return semicolon at the bottom. And whenever you have a void function, then you do a return semicolon. You cannot return anything from a void function. Now, you may be thinking, well, if I'm initializing the function, how do all those numbers get passed back to the main program that's calling it? It turns out that whenever you use an array as a formal parameter, then the information is always passed by reference. So you may recall in a previous program, if we did a call by reference, then the address goes into the function, then the function can change that address any way it chooses. And when the function finishes and returns, then the call by reference means that that information is passed back out. So by default, an array is passed by reference. Now, I'm just going to indicate the syntax. We had a ampersand here, if I can get that up there. And I'm going to take this out immediately. But in previous videos, we did the ampersand in front of the variable name to indicate that we were calling by reference. So why do we not have it here? Why do we not put that in front of the array? Well, this is just one of those many things that you need to remember when you're dealing with a programming language. We need to follow its rules. Since this is by default passed by reference, it isn't necessary to put the ampersand over there. If you got a regular ordinary integer or float or whatever type, if you want to pass it by reference, you do need to put the ampersand. So we aren't passing the elements back out. We don't need to do that. So we can do a call by value for the elements, and we do a call by reference for the array. So make sure that you understand that. Now, let's continue with definition of the function. The function's complete, but we have to do the prototype. So let's copy the first line, and we scroll up to the very top, and it's a long way up to the top. So here we go. Now, we paste in that first line from the function. We add a semicolon. Then here is the prototype that we need. Then we are going to call the function. Instead of initializing the array in this for loop, I'm going to call our init array function to do that. So I need to take this out altogether. So I'll remove the for loop, and I'm just going to call init array. And when I call the function, I need to give the name of the array. It's array 1, and that should be a letter O, comma, and how many elements do I have? Well, I've got size. Okay, I'm using that. And I could have put 100 there. I could just write in 100. But since I'm using the constant size up here, then I want to continue to use that. So if I want to change the size at any point, I just need to change the constant. So this is equivalent to calling init array with array 1 with 100. Another important thing to note, you do not use the square brackets here. There are a lot of tiny little rules like this in C and C++, so you do not use the square brackets when you're calling a function. Now this will initialize array 1. I want to also initialize array 2, so let me just copy and paste and change this to array 2. There we go, TWO. And now these two calls will initialize array 1 and array 2. Now I'm going to leave this other stuff here for the time being, and I'm going to compile and run the program to show you that this works. Now we have the output. So here, this program looks exactly like the other one, but in this case, we are using the init array function to initialize the array. So they're initialized, and then we still print them out with the for loop in the main program. And if you look carefully, the numbers are going to be different for array 2. Okay, that's because in this case, I initialized array 1 completely, then I initialized array 2. Right? And in the previous example, then I had the array 1 and array 2 both inside a for loop. So the numbers are going to be a little different because of the method I used here. But we still get random numbers generated for the array 1 and array 2. Now the next thing that we have that's very repetitive is the print statements. So we have the for loop to print out all of these arrays, array 1, array 2, and all of these arrays here. So that's repeated code, so let's write a function that will print out an array. And it will look very much like this. So let's go down to the bottom of our program where the functions live, and let's write a function that we will call print array. So here's the skeleton for the function. Again, I'm going to make it a type void. It's going to be called print array, and the arguments are going to be the very same thing as we did with the initialize up here. So I'm going to pass in an array. I'm going to pass in a number of elements, and then inside the function, we're just going to print out all those elements. So we can just go ahead and paste the code here. It's the same code that we had earlier that we repeated several times, but I had to make a small change here, and instead of using size that we used in the main program, the function is going to use elements here. So again, we have to declare the integer I, and I have to make sure that I'm using the formal parameter array in our print array function. So this print array function, it can accept any of those arrays. Array 1, array 2, the product array, the difference array, and the sum array. Those all work just fine. And we can call this function once, or we can call this function to print out the array and not have to repeat the code in the main program. Well, let's finish this up because we have to do the other parts. We have to make the prototype. So we'll copy and paste at the very top. We'll paste in the prototype for the print array. We'll add the semicolon. Now we can replace a lot of code. So as we go through our program, whenever I'm printing out information now, I can take out that for loop and I can just call the print array function. Okay, so we can take this out and let's line this up, and I just call print underscore array. And which array do I want to print? Well, it's array 1. And how many elements does it have? Well, it has size, which is 100 in this case. So this will print out array 1. And I can do the same thing for all the other ones. If I want to print out array 2, I can replace that for loop, and I call print array, and I send in array 2. So it prints that out. All right, this is still okay. We'll leave this one alone. This is initializing, or I'm sorry, this is doing the math operations on the arrays, so we'll leave that. But when we finish, we do want to print those out, so we can take out that for loop, and we can print the sum array. Okay, so it's called sum array. Make sure that's exactly correct. Okay, so we need to call that when we're calling the print array. So that's sum array. And on we go here. So we can replace this for loop with the difference array. Okay, so this would be diff array. Well, let me copy and paste this print array call again. Okay, so here we want to pass in the difference array. So that will print it out. And then we'll also print out the product array. Okay, so let's paste that in here. And instead of sum array, we want prod array here. P-R-O-D. Now, we have replaced a lot of the code, so this program is much shorter. It's not repetitive anymore. We could also do a function for the max and min, and I guess we should do that. But let's take what we have and run the program, and let's look at the results that we get. Let's look at the output. So now we have functions to initialize the arrays. We print out the results here with the function print array. So we print array 1, array 2, here's the sum array, here's the difference array. But look what happens with the product array. The numbers are too large, so they run together in cases. Okay, so those are two numbers, but they run together. So we need to modify the function a little bit so that we can pass in the width depending upon the size of these numbers that we're trying to print. So let's go add that to our function. This is pretty easy to do. I mean, the problem is if you look at the print array function, you'll see the set width. So if that's set to 4, then the numbers run together when we multiply them. So let's add a variable for that. So let's call it int width. And instead of using a fixed number here, 4, then let's use that formal parameter, width. Now, we can send in the width when we call the function, and we can make this whatever we want it to be. Well, I've added this parameter, so I need to redo my prototype. So I'll copy, and I'll go up and paste that in. So you can see there's a green line there. Okay, so let's paste that in and add the semicolon, because now we've got the third argument. We have the width in there. All right, now when we call the function, we have to call with the width every time. So in the calls that we make to print array, then we need to specify the width. Okay, so we add a comma, and for array 1, 3 was okay because the numbers were only 2 digits. Okay, the same thing for array number 2. We can make the width 3. When we're printing out the sum, then we could have a little bit larger number there, so let's make the width 4. And when we're doing the difference, then it's a negative number, so we could use 4 there. But in the case of the product, that could be pretty big, and we used 6 earlier, so we'll use 6 here. So now we've added a parameter, and we'll pass in the width. That will help us format the output whenever we call the print array function. So now let's compile and run the program again. Let's look at the output. So now, we had the same format as before for array 1 and array 2. We had a width of 3 for that one, width of 3 here. Then, when we went to the sum, we had a width of 4. So you can see we have 4 spaces there, 4 spaces here. We also used 4 spaces when we were dealing with negative numbers because that we need the space, the dash of 59, so that was a width of 4. And down here, when we have the product, we had a width of 6, so now these numbers do not encroach on each other. So I can see there the width is 6, and the width of all these is 6. So by adding that parameter to our function, we can format the output much nicer. Now let's close out this example by writing a function to find the maximum and the minimum values. So what we're doing here is we're trying to write a function that's going to determine 2 numbers, and it will pass both of those back to the main program. So let's examine how we can write a function that would do that. And this is going to be maybe something different than what you've seen before because we can't return 2 numbers with the return statement. So let's examine what the solution is to this particular problem. Let's begin with what we've done with the other functions that we've written. So if we paste in this beginning part, the name of our function, then it can be a type void, and we want to use find max and min, or I've chosen to use that as the name of the function. And we will need the array that we're using, we're sending in order to find the max and min. We have to send that in, and we need a formal parameter for it. And we need to know how big it is. So we got this. So that's the same as before. But inside the loop, we are going to need to go through each element in the array and determine the max and min values. So here's the code that we had in the main loop, or something very similar to it. In order to determine the maximum and minimum, then we need variables for that. We need to loop through the array, and we check each element in the array. So we could start by initializing the maximum and minimum values to the first element of the array like we did before, and that will be just fine. So let's add the code in to do that. So we can use the same 2 statements we had earlier. The array in, that formal parameter, the array that's coming in will go into this formal parameter here, and then we can just take the first element, set the maximum to that value, and the same thing for the minimum. So this will get us going. That gives us the first values for maximum and min, and then we just loop through with a for loop this time, and we try to find any numbers that are larger or smaller. So if the element that we're looking at is larger than our current maximum, then we just set our current maximum to whatever that element value is. So that's a straightforward assignment there, straightforward if statement. And we'll do the same thing for minimum. The problem that we run into, though, is if we get to the bottom and we want to do a return, then how do we return the information? Well, if we have a void function, then we know that we cannot return anything. That's the nature of a void function. We could change this to an integer. We could do an int, and then down here, we could return the maximum. But what about the minimum? With the return statement, you can only return one thing. If I want the function to return multiple items, then I have to use those reference variables, or those variables that we call by reference. So that's the solution for writing this particular function. I need to add some arguments to our formal argument list that I will use to pass data out of the function back to the main program. So I'm going to declare minimum and maximum up here, and I'm going to make those call by reference variables. So I'm adding those variables in, and here we have the notation for a call by reference. Now the system that I'm using, Visual Studio, it likes to put the ampersand over next to the type, and I don't like it to go there, so I'm going to change that up. So I'm going to make maximum and minimum variables in my parameter list, and I'm going to call them by reference. Now, as you may recall from the earlier video, when you call a function with reference variables, then you're sending in the address of these variables. So within this function, any changes that are made to the variables are passed back out. So it changes the contents that are stored at the addresses of those two variables. Now, since I have moved my declaration of maximum and minimum to my argument list, then I have to remove it from inside the function, because otherwise those will be doubly defined, and it does not allow that. Now, there are a couple of ways you could go about this. I'm showing that you could return maximum down here. So it's possible, if you wanted to do so, you could return maximum down here, and then you would only need to have minimum as your reference parameter up there. If I'm going to return stuff through my argument list using reference variables, then I would like to put them all up there. I don't like to mix up something from here with something up there. So I want my function to return both max and minimum values. So I am going to make it a void function. So I return nothing from here, and I'm going to make this int back into a void. And when I call the function now, whenever I call it, the function will determine maximum and minimum, and it will return those values as part of the calling argument list. Great. Now, let's go ahead and change up our prototypes, or we need to add the prototype for find, max, and min. So I'll make a copy, and we'll add it to our list of prototypes at the top of the program. So let's, I guess I had pasted that in already, so we'll just do it again just to be sure. So Control V to make sure it's accurate. Then we want to call this function to determine the maximum and minimum values. So we need to add the call into our main program. So let's scroll down to the bottom, and here is where we had the while loop to determine max and min earlier. So we're going to replace all of that code, so we'll take that out, and then we'll just put in the call to the function. So we'll call find, max, min, and I want to find the maximum and minimum of array 1, so we'll send that in, and we have to send in how many elements, and we also have to have these parameters. Okay, so in the main program, I have max and min. So when I call my function, I'm going to send it the address of max and the address of min. Then the function will calculate those values, and it will use its own local variables, which you know by now they don't have to be exactly the same. They can be different spellings, different variables. So it returns the information through this calling list, and then in the main program, we will just print out the maximum and the minimum. So that's all there is to it. Now let's compile and run the program. Now we have the output, so let's bring it over. And you can see now that we do get the results, maximum is 99, minimum 0. The reason that we have 99 here instead of 97 is because when I changed my initialization from the earlier case where we had the for loop in the main program, I changed it so that I could use the initialize array, the init array function. And when I did that, I kind of changed the order that the numbers were generated. So array 1 is generated completely, then array 2 is generated. So the sequence of numbers is different than what I used in the first program. At any rate, array 1, it really does have a maximum now of 99, and somewhere in here we have the value 0, which is the minimum. So the function to find the max and the min really does work. Well, that concludes this example, and there's quite a bit here. There's a lot of detail in here. So this illustrates how you can use a function with a one-dimensional array to do a variety of things. So I think that we will close the video at this point.